This video is an introduction to vectors where we're going to look at these 5 aspects. We're going to do so in both 2 dimensions and 3 dimensions, and we're going to see that actually it's the same rules each time. So in 2 dimensions, first of all, I've got a coordinate A, which is 3, 4. So here's my point A, 3 squares to the 3 squares in the x direction, 4 squares in the y direction. Now, the position vector is written like this, OA with an arrow on top. That's saying to go from the origin, O, to the point A in that direction. So this means the position vector of point A relative to the origin. Now, I can write the position vector in 2 ways. I can write it in column vector form, which would look like this. It's saying to go 3 squares in the positive x direction and 4 squares in the positive y direction. That's one way of writing it. Or I could write it like this, 3i, where I represents 1 square in the positive x direction, plus 4j, where j represents 1 square in the positive y direction. So we can write vectors in column form or in component form. Notice that when I am drawing a vector, when I'm writing a vector down, I am underlining it to represent that it is a vector and it's not algebra. Okay, so that's the position vector of point A. Next, these vertical lines here, they represent the magnitude, which is the overall size of a vector. So how big is this vector? How long is the line from O to A? And I can work that out with a little bit of Pythagoras. 3 squared plus 4 squared, all square rooted, is 5. So that's how we can work out the magnitude of a vector. Next, unit vector. So what's this little hat here, the A hat is saying, is that we want a vector that's in the A direction that has a magnitude of 1, hence why it's a unit vector. Now we've already seen a couple of these. We've seen the unit vector I, which represents 1 unit in the positive x direction. And we've seen the unit vector j, which represents 1 unit in the positive y direction. In this case, I want to work out the unit vector that is in the a direction. Now remember, A was there. So I want to know what's the vector that's 1 unit in that direction. Well, I know that that direction can be shown with 3i plus 4j. That's the direction we're talking about here, 3 across, 4 up. The problem with that is that has a magnitude of 5, not 1. So the unit vector I want is actually 5 times smaller than that. I want this, a magnitude of 1, not a magnitude of 5. So all I'm going to do is divide my vector A by 5. That way it will be 5 times smaller and it will now have a magnitude of 1 rather than 5. And you can check that if you like. You can do 3 over 5 squared plus 4 over 5 squared, all square rooted, and you will get 1. So that's how you can work out a unit vector. You take the vector A and you divide it by its magnitude. Right, let's now see that that works exactly the same in 3 dimensions. So I've got the point B, which is the coordinate 3, 4, 12. So 3 in the x direction, 4 in the y direction, and then 12 in the z direction. It's coming out of the page towards you, out of the screen right now towards you. It's obviously impossible for me to draw this accurately in 2 dimensions on the screen, so I'm just going to draw it roughly there. There's point B. The position vector of B then, from O to B in column form would look like 3, 4, 12. And in component form would be 3i plus 4j plus 12k, where k is a unit vector in the z direction. To work out the magnitude of that vector, I would do Pythagoras. So 3 squared plus 4 squared plus 12 squared, all square rooted, is 13. And again, to work out a unit vector in the direction of B, I would take the vector B, the 3i plus 4j plus 12k, and divide it by 13, the magnitude. And there we go. So that is the position vector, the magnitude, and unit vectors. Now let's move on to see what happens when we have more than one point involved. So we'll start off in 2 dimensions. I've got the coordinate A, which is 1, 2, and I've got the coordinate B, which is 7, 10. The position vector of A, so from O to A, is 1, 2, or if you'd prefer, 1i plus 2j. The position vector of point B from O to B is 7, 10, or if you'd prefer, 7i plus 10j. A to B, that's telling me the position of B relative to A. It's a relative vector. It's saying how to get from A to B. Now, at the moment, I'm not quite sure what that vector is from A to B, but we can work out really quickly and really easily. Basically, I'm just going to tell you a rule here, and I'll show you where it comes from. We do the vector OB, the position vector of point B, minus the position vector of point A. The position vector of point B, the position vector of point B minus the position vector of point A. I'll show you why that rule works. You might be able to spot it for yourself, but I'll just show you quickly why that works. So, A to B, if I want to go from point A here to point B here, now I'm going to go a slightly different route. I'm going to go from A to O, which, notice that's in the opposite direction to the vector OA, the position vector of A. And then I'm going to go from O to B. So I'm just taking a slightly different route to get from A to B. So I can say A to B is equal to A to O plus O to B. Now notice that A to O, like I said, that is exactly the same as vector O to A, but in the opposite direction. So this equals minus O to A, because it's in the opposite direction. And then, just to tidy this up a little bit, I'm going to put the positive term at the front, the OB minus the OA. So that's why this rule works. That's why, if I want to work out the vector from A to B, I will do B take away A. Which, in this question here, then, will give me 7, 10, that's my position vector of point B, minus A, is that, which is 6, 8. So, to work out the magnitude of that vector then, I could just do a bit of Pythagoras. So 6 squared plus 8 squared, all square rooted, which is 10. Or let me just remind us where that 6 and the 8 came from. The 6 came from the 7 minus 1. The 8 came from the 10 minus 2. And hopefully you'll remember, this is ringing some bells from the work we've done on coordinate geometry before. Right, let's now have a look in 3 dimensions. Now, like I said previously, it's impossible for me to draw accurately in 3D, so I'm not even going to try. I'm just going to say that point C is here, point D is here. I'm not even looking at the coordinates here, I'm just putting them in random places, to be honest. And my origin O is there. The important thing is that this is the position vector OC, which is 1, minus 2, 4 from here. And this is position vector of D, OD, which is the 4, 1, 5. If I now want to work out the vector CD, so just like I did in 2 dimensions, CD is going to be equal to OD minus OC, the position vector of D minus C. D minus C. Which would be 4, 1, 5 minus 1 minus 2, 4, which would give 3, 3, 1. I could then work out the magnitude of that, the length of that, the distance between C and D by doing some Pythagoras, which would give root 19. So the magnitude of CD, the length of this line, the distance between coordinates C and D is root 19. And there we go.